Hi everyone. Hi sir. I am Vardhan from ECE third year. Now I'm going to cover some topics in satellite communication. Uh, Summary of this video is I'm going to cover Kepler laws, orbital elements, types of orbits, orbital effects, frequency allocations. Introduction to satellite communication. Definition of satellite communication is a satellite is specialized wireless receiver transmitter launched into orbit to use for communication. History of the satellite communication is it is started with Sputnik 1 in 1957 and evolved into multi-billion-dollar industry. Role of satellite communication acts as a repeater in space. Role of satellite in communication is it acts as a repeater in space, receiving signals from the air and retransmitting them onto the air. Key components of satellite are the space segment and the ground segment. The space segment is related to the satellite which is present in the space, and coming to earth segment means the transmitters or the receivers we are having on the earth surface to receive the signals which are transmitted from the satellite. Uh, Advantages are global coverage. We can cover whole part of the globe. We can connect continents and other countries which are far to communicate. Point to multi-point communication and distance intensive cost. At low cost, we can communicate with the distant places. Limitations of this satellite communications are high initial launch cost. It takes more, it costs more to launch a satellite into space. Yeah, propagation delays. Sometimes information transfer occurs some delays between the communication and finite orbital slots. As the space is limitedly explored, we have limited orbits to launch the satellites. So it is very complex complex part to launch a satellite into the space. The fundamental challenge is maintaining a stable orbit while ensuring the high signal quality. The complexity is to handle the specific orbit path in which the satellite should rotate. If the orbit changes its position or the direction or the path, the communication discontinuous of the communication occur. So the fundamental challenge is maintaining the satellite in the same position. Now we are going to move into Kepler laws. The law of ellipse statement. The Kepler law. There are three laws in Kepler. The first law states that the orbit of the satellite is in the shape of ellipse, in which the Earth is located at one foci point, and there are 2 points in this ellipse. One is perigee, and another one is apogee. Perigee is the point at which the satellite comes closest to the Earth. Apogee is the point at which the satellite moves away, which means it is the farthest point from the Earth's surface. The ellipse describes the shape of the orbit. The shape of the ellipse is defined by the eccentricity orbital element, which decides the shape of the ellipse, highly elliptical or medium ellipse. In this way, if the eccentricity value is equal to 0, then the shape of the orbit is circular. If the eccentricity E is greater than or less than 1, not equal to 1, then the path of the orbit is highly elliptical. Impact signal strength fluctuates slightly as the distance changes throughout the orbit. As the satellite move away from the Earth, that means reaches the apogee point, the signal, and the noise increases. Whereas when the satellite comes close to the Earth, means when it comes at the perigee point, the signal quality becomes high. In this way, the distance between the Earth and satellite varies, also affects the signal quality. Communication design. Engineers must account for path loss variations due to this law. Now we are going to discuss about Kepler's second law, the law of equal areas. Statement of this law is a line joining the satellite and the Earth sweeps out equal areas in equal intervals of time. This means that, if we take a point on the ellipse, the satellite moves to another point on the ellipse, the total cover, the area covered from the Earth center and the path covered by the satellite is equal to any point on the ellipse. Now we are going to discuss some topics in Kepler's second law. First one is orbital velocity. This law proves that satellites do not move at a constant speed, perigee speed. The satellite moves at its maximum velocity when it is close to their apogee speed. The satellite slows down in the minimum velocity when it is farthest way away from the Earth. Angular momentum. This law is direct consequence of the convergence of angular momentum. Synchronization. Circular of TDMA means time division multiple axis systems to maintain timing. Dwell time explains why satellite hover longer over areas near the apogee point. Now we are going to discuss about Kepler's third law, the law of harmonies. Statement: the square of the orbital period t is proportional to the cube of semi-major axis. Now we are going to discuss some points in this Kepler's third law, which are altitude versus speed. The higher the satellite altitude, the longer it takes to complete the orbit. Geostationary requirement used to calculate the specific altitude, that means 35,786 kilometers of a 24-hour period. The satellite should cover the distance of 35,786 kilometers in 24 hours, which matches the Earth rotation around it, which means the satellite moves parallel to the Earth with same speed, which requires only one transmitter or receiver station on the Earth, which is very useful for TV broadcasting and broadcasting. Next, we are going to discuss about significance of Kepler laws in analysis. Position and prediction are analyzed by the Kepler laws. These laws allows us to calculate the exact future position of the satellite, which helps us to correct the position or the orbital rotation. We can also find the fuel consumption, and we can manage the fuel consumption. We can avoid the collisions between the asteroids which are present in space. We can change the direction of the satellite when it is nearer to the obstacles, and we can reduce the damage caused by the space objects. Launch windows determines when the rocket must be launched to reach the specific orbital slot. Coverage mapping, it helps to predict the coverage area which is covered by the satellite by these Kepler laws. Link budget, we can calculate the budget before launching the satellite by these Kepler laws. These are the advantages of Kepler laws in analysis. Now we are going to discuss about classical orbital elements. We Classical orbital elements basically tells about the shape of the orbit, orientation and the direction of the satellite, altitude. All these accepts. There are 6 parameters that are required to identify the satellite's position and its path. Uh, we are going to discuss about that 6 parameters. Those are defining the size and shape A and E, semi-major axis A, half distance of the longest diameter of the orbital ellipse, significance of A. It determines the energy of the orbit and the orbital period, eccentricity, as we discussed earlier, the ratio of the distance between the foci to the length of the major axis, which determines the shape of the orbit. If the eccentricity is equal to 0, that means E is equal to 0. It denotes the orbit is in circular shape, whereas the eccentricity is between 0 and 1. Then it is known as elliptical orbit. If it is greater than 1, it is highly elliptical orbit. Uh, Defining orientation and inclination. Definition: the angle between the orbital plane and Earth's equatorial plane. Range measures from 0 to 180 degrees. E- Equatorial orbit. When I is equal to 0, the orbit is known as equatorial orbit. Geostationary satellites to stay over the equator. This I is equal to 0. Inclination is maintained 0 when we launch a satellite into geostationary orbit, which rotates parallel to the Earth's equator. Polar orbit I is equal to 90. These are the satellites which are launched in highly elliptical orbits when the inclination of these orbits is I is equal to 90. Orientation to nodes and perigee are a ran right ascension of ascending node than significance. It defines where the orbit plane twists relatives to the stars. Ascending node, the point where the satellite crosses the equator moving from south to north. A reference point measured relative to the first point of Eris. Augment of perigee, the angle between the ascending node and perigee. Significance, it tells us where the closest point of the orbit located in the plane. Now we are going to discuss the position, mean omni anomaly. Mm. Definition: describes the satellite position at specific time. Mathematics is for it is a fictitious angle that increases uniformly with time. Relation: it connects the time elapsed since the last perigee passes to the satellite position. True anomaly: this actually physical angle between the perigee and the satellite position. This is the diagram which shows the all six orbital elements considering the shape and orientation and the inclination of the orbit. This is the diagram which includes the inclination, true anomaly, argument of perhaps, reference direction, plane of reference, orbit, longitudinal of ascending node, these angles and the shape of the orbit. Now I am going to discuss about the types of orbits and merits, demerits. In that there are totally four: LEO, lower Earth orbit, medium Earth orbit, geostationary Earth orbit, highly elliptical Earth orbit. First, we are going to discuss about low Earth orbit. Typically, it is 500 kilometers to 2000 kilometers away from the Earth's surface. Merit low latency. Propagation delay is minimal. The propagation delay minimal means the signal when transmitted from Earth station to the satellite and processing